Hello, class. I hope everyone had a nice weekend, but we are going to jump right into today's lesson, which is about the carbon cycle on Earth. So let's begin with what is the carbon cycle? The carbon cycle is a process where carbon moves between plants, animals, microbes, minerals, and the atmosphere. This allows nature to reuse carbon atoms, which travel from the atmosphere into organisms and then back into the atmosphere all over again. As a result, carbon is always in a constant state of movement from place to place. This carbon is stored in many places known as reservoirs. Carbon can move between these reservoirs through a variety of processes, including photosynthesis, burning fossil fuels, and simply releasing breath from the lungs. Some reservoirs, such as rocks and fossil fuels, contain vast amounts of carbon from plants and animals that lived millions of years ago. However, a majority of carbon is stored in the ocean. Well, you might be thinking, why is the carbon cycle so important anyways? Well, carbon's essential for all living organisms. Whether these life forms take in carbon to help manufacture food, or release carbon as a part of respiration, the intake and output of carbon are components of all plant and animal life. Without human involvement, nature tends to keep carbon levels balanced. The amount of carbon naturally released from reservoirs is equal to the amount that is naturally absorbed by reservoirs. Maintaining this carbon balance allows the planet to remain hospitable for life. So, how does this relate to the climate change we've been studying? Good question. Let's take a look at it. As mentioned previously, the carbon cycle by itself is very balanced. However, with the addition of humans, we start to have major issues. Humans are adding more carbon to the atmosphere than the Earth can naturally eliminate. 85% of all CO2 emissions are produced by burning fossil fuels, which includes coal, natural gas, oil, and gasoline. On average, humans add about 1.4 metric tons of carbon every year per each individual person. Human activities have raised the atmosphere's carbon dioxide content by 50% in less than 200 years. Before the Industrial Revolution, CO2 levels were consistent around 280 ppm for almost 6,000 years of human civilization. Since then, humans have generated an estimated 1.5 trillion tons of CO2 pollution. The top three producers of carbon dioxide are China, with more than 10,000 million tons of CO2 released, followed behind the United States with 5,000 million tons of CO2, and finally India with about 2,000 million tons of CO2 released. The average person in the United States produces 20 tons of CO2 alone. This is due to many sources of the carbon cycle directly tied into our own lives. Most commonly, the usage of cars being the most abundant source of carbon dioxide production. Second is the use of fossil fuels to produce energy for our homes. Thus, as humans change the atmosphere by emitting more carbon dioxide, this is why we've seen a steady increase as the Earth cannot naturally eliminate all the added carbon. Climate change is the long-term shifts in temperature and weather patterns. These shifts may be natural, but since the 1800s, human activities have been the main driver of climate change, primarily due to the burning of fossil fuels. The results of these changes are very harmful to the Earth. The ocean, for example, absorbs 30% of all CO2 released into the atmosphere. However, the more carbon the sea absorbs, it will slowly lower its pH levels, making it more acidic. This will, in turn, affect the ocean environment as many sea creatures rely on the stability of the ocean's pH levels to build shells, grow, and hunt. Millions of years ago, the ocean originally had a pH level of 7.8, and now has a pH level of 8.1. If this trend continues, we could be looking at an acidic ocean. The increase in CO2 in the atmosphere has also had some significant effects on the planet. Temperatures are rising worldwide due to greenhouse gases that are trapped in the atmosphere, as well as an increase in droughts, which are becoming longer and more extreme in the world. As the temperatures continue to rise, there is less snowpack in mountain ranges and polar areas, resulting in the snow melting faster. Sea ice in the Arctic Ocean and around the North Pole are also melting faster with warmer temperatures. Permafrost is also melting, releasing methane, a potent greenhouse gas, into the atmosphere. As a result, sea levels are going to continue rising, threatening coastal communities and ecosystems. Glad of you to finally join us, Mr. Miles.
Sorry I slept in. What are you guys doing? The carbon cycle? I already know this.
Well, if you know this topic so much, Mr. Myers, then why don't you teach this portion of the lecture?
Sure. So like carbon sequestration is described as capturing and storing atmospheric carbon dioxide. It is one method of reducing the amount of carbon dioxide in the atmosphere to reduce global climate change. There are three types of carbon sequestration. Biological carbon sequestration, where the storage of carbon dioxide in vegetation such as grasslands or forests, as well as in the soils and oceans. There is also geological carbon sequestration and technological carbon sequestration. In reference to plants will use photosynthesis, which is the process in which light energy is converted into chemical energy in the form of sugars. In this process, the plant takes in water, carbon dioxide, and light energy, which is given off by the sun, man. Driven by light energy, the chloroplast cells of the plant begin using the reactants and will produce glucose molecules along with the oxygen, which is released as a bioproduct. Oh, man, the plants will then use this glucose to feed themselves through cellular respiration. The cellular respiration will produce ATP, which can be used by the plant for its energy needs. Yeah.
Go take a seat, Mr. Myers. Now, let's specifically take a look at how trees affect carbon sequestration. Before class, I went out and took a picture of this tree. Now, to calculate the total amount of carbon that this tree has sequestered, we must gather specific data. Using the distance away from the tree, as well as my height, we can use trigonometry to calculate the estimated height of this tree. We also were able to find the circumference of this tree, which then allows us to find the volume, and in turn allows us to find the green volume of the tree. Using this green volume, we can estimate the theoretical pounds of sequestered carbon in this tree. I was able to calculate that there is an estimated 100,000 pounds of carbon sequestered in this tree alone. Knowing this, we can see how important trees are to sequestering carbon, as there absorb vast amounts of carbon from the atmosphere.
Well, knowing this, why shouldn't we just plant more trees if they're amazing carbon vacuums?
That's a great question, but the answer is a little bit more complicated than that. Well, planting trees has some benefits, however it has many cons. The answer seems simple at first, on the surface, but looking deeper at the subject we see different things. The most important thing to note is that planting trees will not solely save the environment, but if done properly, will help offset some carbon emissions. Another misunderstanding is that by planting trees using monoculture methods is actually hurting the environment, as it destroys the ecosystem. With all this taken into account, planting trees can help the environment by taking out some of the carbon, but will not solely save it. But an issue arises when planting trees in some specific areas, as it can actually cause an increase in temperature to rise there. However, there are other ways we can combat climate change. One way is people to switch over to a plant-based diet without reducing the number of fossil fuels. The agriculture industry makes up 18% of all global emissions, and beef, in particular, makes up half of that. This means that the beef industry makes up for more carbon emissions produced than all the planes, cars, ships, trains, and trucks combined. Plant-based companies, such as Impossible or Beyond Meat, are helping people make the change to switch from a plant-based diet, which will in turn help the environment, as it will allow them to cut down on emissions made by the agriculture industry. The biggest thing countries can do to affect the carbon cycle is switch over to clean energy. The main contributor to the rise of climate change is the emissions of greenhouse gases, which most commonly occur from burning fossil fuels. While this method does not remove carbon dioxide from the atmosphere, it is the most significant stepping off point for the world to stop adding carbon dioxide to the atmosphere. We must stop the additional carbon dioxide production in the atmosphere before we can tackle the issue of removing it. These clean energy produce 90 to 99% fewer greenhouse gases than the traditional fossil fuel burning plants. Knowing this, we should all try our best as individuals to come together to combat climate change. Only one person will not make a difference, but together we can change the world for the better. Class dismissed.